This graph is, I'll just step you through this. We've got 3 lines here, and again this relates to Australian football. It's only more recent times from about 2002 to one data point for this year. The blue line represents the average play speed, which is essentially what I showed last graph. So the play speed, which is the ball speed. It's the video tracking of the ball speed. And as you can see, it's going up, as I showed previously. I'm not sure if, here we go. This line here is a summary. Each data point is a summary of anywhere from a few hundred to a couple of thousand GPS files that are collated centrally in the AFL. So all the clubs, or most of the clubs, send their data to one person or one company, and they summarise them and put this data together. And so for 6 years it has increased up until that point there. So the blue line is the ball speed, this is the player speed. You can see they're generally trending in the same direction, that is up. And at the same time, we also have this black line here, which you can see is trending up, which is the injury incidence. So this is the number of new injuries per club per year recorded in the AFL. And you can see that it's also trending up in similar sorts of ways to the other 2 lines. So that is very suggestive that they're linked somehow. Maybe not cause and effect, but it is perhaps reason to explore a little bit further the possibility that they are linked. And it makes intuitive sense that they might be linked. Even if you imagine players running faster on a field and colliding by accident, there's greater potential and probability of that just by randomness or by chance. If they're moving faster and having a significant injury than if they're moving more slowly. But in 2011, so this year, there was a substitute introduced because of the concern that these were linked somehow, that they're all going up, and so therefore there may be some sort of causal relationship there. The early data, and this is only from one club I should point out, normalised to that point there. The data from one club, are about 140 games, player games, suggests that there hasn't been an increase, and it may in fact be a significant decrease as a result of changes to the rules that prevented players from getting as much recovery as they did previously. So instead of 4 freely rotating interchange players, there were 3 rotating players and 1 substitute in a similar way to soccer, where that player could only go on when another player came off permanently. The other thing that I'll mention in terms of the Australian Football Code is this issue of player density. Now, player density is measured by using an ellipse on a video recording where you stop the footage, usually because player density around the ball is a continuous variable. It changes, you know, in milliseconds. Then the way in which we have decided to measure it is by stopping the video at a set point along the game. And we've chosen, sometimes we've chosen 10 seconds, others 15 seconds. So in a sense we're saying we'll stop the game every 15 seconds while it's in play, and we'll check using an ellipse that is calibrated, if you like, against their best estimate of the heights of the players and their position on the field, to count the number of players within 5 metres of the ball. And using the same people to do this over years, we feel that we've got, and we've done our reliability checks with those same people, and we get pretty good reliability when they do the same game multiple times, for example. But this is just data from 2006 in green, 2009, 2010. So we've got 5 seasons of data. We don't do every season for player density because we'd have to measure more games, I think. But what we can see is that if we look at the number of players within 5 metres of the ball, and these numbers are increasing, so this is a really high density here. You can imagine 16, 17 players around the ball within 5 metres of the ball is extremely high. Even, you know, this number here is high in terms of the demands on the players for decision making and skillful movements to release the ball and get it out. But you can see that the red 2010 frequency distribution here, it's skewed, obviously, all these are skewed, tends to lie at the top of these distributions. So there are more, there's a higher frequency when, in this case, say 6 players are associated around the ball or are located around the ball in 2010 compared to 2009 and compared to 2006. So because the red is high, you can see player density, and using non-parametric statistics, it is significant change even in that short period of time. So player density has increased very dramatically over the last few years as speeds have increased and other things have changed, and hence part of the rationale for the AFL to try and change the rules, to try and do something and reverse this congested play, and I'll talk more about that in my AFL presentation on Monday. In terms of rugby union, what similarities, what differences do we see when we look at the highest level of rugby union? So this is a World Cup games for rugby union, and I'll present the data like this. This is game speed again, so this is the ball, metres a second in ball movement. Now the first, and this is a scale from 3, 4 up to 8 metres a second, from the World Cup 87 through to, in this current slide here, 2003. So the first thing we notice that's different to soccer and different to AFL is that the speed of the ball has gone the other direction. So the speed of the ball, the movement of the ball, the general movement of the ball in rugby union has slowed. And part of what we were asked to do by the ARU and Eddie Jones in particular, in between 2003 World Cup and 2007 World Cup, was to work with them to say, well, look, what can you tell us about the trends, the overall trends in variables like the speed of the game, the ball movement, the player density, the physicality and so on. What can you tell us about the trends in the past that might be able to help us predict where the game might be in 2007? So you have to remember this was in between 2003 and 7. Obviously they wanted to get some sort of insight and perhaps train towards those general patterns. So we said, not being an expert in rugby, well, as a coach, what do you think are the best examples of play periods that last at least 60 seconds or so in rugby that you can pick, that provide a benchmark that you would see as a benchmark or best quality play in international play? So many of them didn't involve the Wallabies or the Australian side and involved other countries from around the world, but he had his technical people and he sat down as well and said, well, this is an example, and I think it was about 7 or 8 minutes of what he called benchmark plays that represented what he would like the Wallabies to be able to do for a large part of the next World Cup, 2007. So when we had a look and measured the game speed or ball speed in those benchmark plays, that's where it fell. Now he didn't know this information beforehand. We put this together afterwards. But it was interesting that as a coach, he predicted, you know, that's where he visualised, if you like, that's where I want my team to be able to play. And in fact, fell what you would agree to be a fairly linear pattern of where the game was heading. So after the 2007 World Cup, we actually obviously measured the game speed, and you know, it's a small increase from there, but certainly in the direction of what the coach anticipated would be the requirements and turned out to be the requirements. He did the same with player density. We took those benchmark plays that he put together and measured again the density of the play in the previous 5 World Cups, and had Eddie put together his benchmark plays, and for the 2007 World Cup that's where it ended up. So he knew that there was a trend towards it. He anticipated a need to be much better at congested play, and that the density would go up and would need strategies to be able to overcome those constraints, if you like, or those patterns of play in the game. And finally, the physicality. Now, rightly or wrongly, this is how we looked at it. We counted the number of players involved in each of the collisions or tackles multiplied by the number of tackles, and we rated the collision or tackles as a 1, 2, 3, as we had done previously in some of our AFL work, using a rating scheme that has been published for rugby anyway by some New Zealand colleagues. So it's a fairly gross measure, if you like, how many tackles, how many players are involved in each of the tackle, and when you use that sort of consistent, albeit gross method, we see a trend over time in the need to be physical, the opportunity or potential to be physical and be involved in collisions and so on. And there was a big anticipation there in terms of the physical nature of the game, and he was pretty close. That's where the World Cup 2000 ended up. And without knowing too much about what's happened in the game over the last couple of years, but just watching it, not measuring anything, anticipate that you would see that linear trend increasing. And whilst I wouldn't bet my house on it, I would be reasonably confident that that's probably the direction it'll be going. So what's changed more specifically within the rugby union? The total play time per half, unlike soccer, again, the speed has gone down, and unlike soccer and AFL, where the total play time had decreased over several decades, here the play time was increasing. Now, it's increasing because the number of stoppages were decreasing, and also the duration of some of those stops was fairly constant. They weren't going up. So what we noticed then, if you summarise the average duration of play period here for the Rugby Union World Cup, we see that the average play period duration has gone from something like, and this is a play which is interrupted by a stoppage where players get some sort of break. It may only be very short breaks, and individual players may actually be moving during that break, but on average that's what we're talking about. It's gone up from an average of about 14 seconds, almost doubled here at 28 seconds across those years. But at the same time, whilst there was an initial increase in stop period time, that's dropped dramatically. So combining shorter stoppage time with longer play period time gives you an insight into the physical demands required in a game which has also gone up much more in terms of the physical demands as well, in terms of collisions and tackles. So more collisions, more tackles, longer play periods, sustain it longer, and less break and recovery time when you do get a stoppage.